All right, STEM Chemers, here is your quote-unquote semester 1 review. So the first half of our course looks at units 1 through 3, and that is what would traditionally have been in our first semester. This is what's getting you that first half credit of your grade. So this year throughout STEM Chem, we're trying to make some real world connections and relate back to climate change and the environment. And so the thread for these first 3 units, we started with some just direct investigations into climate change through Unit 1 and properties of matter and all of that. Then jumped in and looked at nuclear power as a potential solution, allowing us to kind of tumble into atomic structure and the periodic table. Then as we broke into looking at ions and compounds, we started thinking about, okay, how do we get these elements and compounds and whatnot from the Earth? What effect does that have? And then later on in Unit 3, dug into water pollution, looking at some of the special properties of water and how that can, why water pollution is such a bad thing. And again, we will continue that thread through the second half of the course, but that's kind of what the thread has been so far, and you see some of our higher value assignments relate back to that. So if we look directly into the content, Unit 1, we look at properties of matter. And so for Unit 1, right, if we zoom in here, we've got properties of matter, and our key focuses here have been, right, climate change in general. That was our backdrop there. We looked at states and properties of matter, so solids, liquids, and gases. What specific properties do they have? What properties are intrinsic versus extrinsic? What is extrinsic? What does that even mean? So on and so forth. We then worked on small particle models, right? Modeling and using our understanding of the particulate nature of matter and what is going on at that atomic or molecular or whatever your small particle model is at that small scale, okay? We used that to investigate kinetic molecular theory, or KMT, and then we used KMT to help us understand and explain a few different phenomenons related to density, thermal expansion, and the gas laws. We also did some lab work around around density and gas laws, and some of that small particle modeling around those as well. We should be able to solve some math problems around the gas laws and around density. Thermal expansion is more of an understanding of what's going to happen. We didn't do any math around that. All right. High value assignments for Unit 1 are really going to be that climate change project, the 2 labs that we did, the bigger ones, the density lab and the gas law labs, where you did the writing, you did the claim evidence reasoning, you did some of the graphical work to understand these concepts. Both of those are pretty high impact. And then also, of course, the Unit 1 assessment, whatever you ended up choosing to do for that. Okay. All right, moving on to Unit 2. So Unit 2, right, we looked at atomic structure and, sorry, making you a little seasick there, atomic structure and the periodic table. We'll just kind of kill some of that title in Zoom. So our topics of focus here, right, we are looking at nuclear power. That was kind of our bridge in. Looking at nuclear power brought us to thinking about nuclear stability, what's going on in the nucleus of an atom, building onto atomic structure, all the way out to the entire, structure of an atom, protons, neutrons, electrons, what's in the nucleus, what's not in the nucleus, and so forth. We understood and we figured out and understood what isotopes are. Then we started doing more modeling, playing with the Bohr model, and seeing how that helps us understand the structure of the atom and what's going on there. From there, we moved forward into basic geography of the periodic table. How do you navigate it? How do you use it? And then we dug real deep into periodic table trends. And from there, kind of finished off the unit with ions, ready to springboard into bonding moving forward. High value assignments here. We're looking at our nuclear power options, right? That opinion paper you did, that was definitely a wonderful showing of your knowledge and efforts with regard to that aspect. The Bohr model shrink cups assignment, right, that assessment piece was looking at can we understand what the structure of the atoms are and how to do Bohr models and so forth. Our periodic table modeling, in particular, the final assignment you did there where you then were also explaining the trends that you were developing with the hands-on modeling. Obviously, the Unit 2 assessment, and then the Group 1 and 17 predicting trends dry lab. that you did that really wrapped up that trends work. Those were kind of the bigger hitters, I would say. Then for bonding, unit 3, right, we're looking at, here, let's go over here with the yellow. We're looking at ionic compounds, right? We're both looking at names and formulas, that translation piece, but then with ionic, remember, we're also being able to determine the formulas from whatever elements or ions that we are working with. We also looked at covalent compounds, and then for that, we just looked at the names and formulas, the translating piece, for those binary covalent compounds. Remember, beyond that, you don't have to be able to know anything about naming or coming up with formulas or anything. It'll all be given to you. We learned about Lewis dot symbols and Lewis dot structures, and then rolled forward into understanding bond character, polarity, and that got us to being able to understand intermolecular forces. From intermolecular forces, we're able to then take a bigger picture look and really say, okay, we can now say we understand some basics at least of those bulk properties of covalent, ionic, and metallic compounds. And then lastly, we throughout, we looked at a couple of different projects that showed kind of the impacts of materials on the environment, both, finding them, extracting them, using them, distributing them into the world, whatever. Again, high value assignments here. We've got that elements in and from nature assignment, that bridge activity that made you kind of think about how these different pieces might connect. The different quizzes on this one, especially for the naming and formulas and stuff, that's the most valuable peek into that I can have as far on that basic level. Your water pollution infographic, kind of tying those special properties of water back into kind of our bigger picture ideas. The IMF lab poster, right, where you did the poem and the model, or the cartoon, or the connection to the real world. Chapstick engineering project, which you guys are just working on and finishing, and then there will be a Unit 3 assessment that we will do as well, and that'll be that. So that is our big overview picture of what did we have going on through semester 1. So after going through this, take some time, look at your work, think about what you've done and what you've learned, and then go ahead and move forward with those, with the self-evaluation work when you're ready. Okay? All right? Have fun.